Okay, perfect. Now we are going to the last talk for today. Daniel will speak and show us the news for the KEMI scripting language, for this KEMI framework, and how to optimize it for your setup. Thank you, Daniel.
Thank you, Henning. Okay, so ready for the last session, and then we'll have like 1 hour break. Then we'll meet on the riverside for the boat trip. You know, probably as you have been, or those that have been in the last few years, that I kind of presented about this KEMI, which stands for Kamailio Embedded Interpreter Interface. We started a while ago with support for external scripting languages. You know, we have our own home-brewed scripting language that started back in 2001. It's kind of a minimalistic design, mainly because at that time there are not many options for high-performance scripting engines out there. So Perl was there, but not really targeting performance, and even now it's not targeting like parallel and recurrent execution of the same script. Python got a lot better lately, but in the past was like huge and slow. And then as we evolved it, at the beginning was good enough, our scripting language from many perspectives, bringing a lot of flexibility, but lately the world of IT, and especially this cloud-related technology, exploded. So all this NoSQL, for each new technology out there, you will have to write sort of a C module for Kamailio, and sometimes it's a little interest from maybe main developers, but some company wants that because they already use it. So trying to somehow please everyone and come in expectation of integrating with all these technologies. I saw that having this kind of native support for executing Python, Lua, we have even Ruby now, JavaScript, it's quite important. And then was also this kind of requirement that reloading the routing logic without restart. So that's possible with this so-called KEMI framework and these external scripting languages. My talk now, it's going to be about optimization that I found during these 2 years of KEMI support in Kamailio, because of course it was at the beginning, and then I discovered as I deployed in production some of the operation could be more optimal. So just to get everyone in the context, if it's your first touch with this framework, so here I have an example of our native scripting language where we have these route blocks, and inside them we have function like condition, if condition, execution of the function from the modules or other subroutes. So this is how our scripting language looks like. And then just for comparison, how it will look the same kind of execution. Sorry, I went back. With here will be with Lua. So we have the equivalent of the previous route block with the native scripting language, and here it's in Lua. Practically, you see this KSR module exported to Lua, and then Kamailio is the interpreter of the Lua, and then you have sort of function to do the same kind of condition as in native scripting language, adding headers, executing now another Lua function because it's their own language. And quite important, just have in mind here we execute this KSR X exit, so it's still part of Kamailio exported module, but is not the exit from Lua. And be careful with this one, because now Kamailio is the interpreter. If you do exit in Lua, it means stop Kamailio. So probably you don't want to do that in production. Use the one that we exported via KSR module, which is practically stopping the execution of the Lua script for that request or reply, and we'll continue with the next message on the wire. So there are some differences, but there is always a trade-off between flexibility and the benefits from one side to another. And just for comparison, this would be for Python, as I noticed that Lua and Python are the most popular from what I implemented so far, with Ruby catching up because of the Andrew there. So this would be the equivalent of a Python, function, or defining a condition and then adding header, executing another function in Lua and exiting. So it's quite similar. So here I'm trying to focus on what improvements in terms of performance you can do related to the Kamailio code that we export to Lua, or the usual condition you have in the native Kamailio config file. Of course, if you use some whatever Python library from out there, is not our job. If it's a poor implementation, it's going to slow down your Kamailio execution of that of your own scripting. So the focus is whatever we implement in Kamailio should be as fast as possible. And then whenever you need to integrate with external system and you use external library, it's up to you to test it and be sure it's up to the performances you expect to be. Finishing this part with a link to our listing of the function exported to the KEMI framework. We still miss the IMS module, but this is part of a bigger project that we'll try to address as we discussed during the discussion panel. But otherwise, here is the listing. You have the prototype, and you have to match it with the module documentation. One of the goals, and I'll have it tomorrow when I present the plans for the near future of the project, will be to unify this KEMI and module documentation in some way that's convenient for the developers and for the users. So yeah, we designed it at some point, and then we started to run it. I got some feedback from the customer. I also watched it. There are some module parameters as well as core parameters that you can measure the latency of executing actions, and also the latency of executing these main route blocks and main callbacks. So I noticed some differences, and then I tried to profile, and then I added some alternatives like functions to get it close to the native scripting language. So the last KEMI Performances measurement, I did it just before the release of 5.2, which is the latest stable branch. So if you run it, you got this already in production. And if you plan to play with KEMI, you'll discover by the end of the slide that in terms of performances is no difference, only maybe some benefits from time to time. So I did it actually on this computer running on a virtual box system with Debian testing. And again, it was the idea to compare between the same operation done with Kamailio CFG and the same operation done with Python Lua scripting, those KEMI scripting. It was not about a very complex configuration. I was looking at the registration with authentication, so some real life scenario with username and password stored in the MySQL, running 20,000 transactions, of course, with challenge back and follow up and some retransmission because of the high rate there. And there is a link here. You can go there. You have the scripts, including the CP script, this CP performance tool that I used for generating the traffic. Everything is there, and you can try replicate it yourself in your environment or for your config and see how it's going for you. But again, it was not like having a very fancy, powerful system out there. It was more in the same environment, how we compare one and another, like scripting languages. And to start with the conclusion or with the results, practically there is no big difference between Lua or at all between Lua and native. Actually, Lua compiles to binary code, so like native code, it's executed by Lua interpreter. And again, Lua interpreter is now Kamailio, as we link to the library. It's not an external execution. Slightly different, but really minimal with the Python. When I did it with the previous version of Python, was way slower. So Debian testing as the new version of Python, and it's way faster. I was pleased to discover that we were more or less in the same range of capacity. So practically, if with Lua, we even got the average better than with the native scripting, and I will explain why that might happen, while the minimum execution of this request route for register with authentication was better with the native. But also, these are microseconds, so 1 millionth of the second are this number. This is the counter, and then the sum, the all execution time, and then the minimum, maximum, and the average of all this execution for all these 20,000 transactions that I pushed out. So some remarks here. So those minimum are practically when we got this initial register without authentication headers, and then we quickly replied with 401 from Kamailio. Then when we needed to do database lookup was more to the higher maximum of the execution for the route block. The limit was like 4,000 registration per second with 10,000 active transaction at the same time, with maximum limit of this 20,000 sent request. And all this operation practically require also updating the records in the database and in the memory as well. With it was practically the native default config file for Kamailio. So again, you have the metrics there also in the wiki page. So when I did it first for 5.0, as I said, I got some differences, and I tried to optimize along these 2 years as I discovered. This, I did it actually on the first phase, but I tried to explain it here so you understand that execution of a Kamailio function in Lua or in a native scripting language is not big difference. It's only one array index access for the pointer. So we have an array that we expose with function that we fill when we load modules. When the modules are finished to be loaded, we expose that to Python or Lua, and then practically we get a callback with an index of what function in this array we need to execute. And then we have everything that we need. So it's from the point of view of finding a function, either via our native config file interpreter or via Lua, Python, this is very fast. There's no difference in time, in computing time. So we have some static array behind it, and it's very fast. What's different and where are some, let's say, penalties would be this pre-compilation of the parameters, in the way that sometimes in Kamailio, if it's a static string, and typically this is with regular expression, we parse at start time. But if you use regular expression with variables, we parse the regular expression with each iteration, each execution, because the value of that variable, it's different for each execution. So this part with regular expression, static ones, the solution here would be if you just do a search for Lua or Python and so on, they have their own search by regular expression, and probably they optimize how they pre-compile it in memory. Otherwise, you could use dial plan module, and you put your regular expression in the database as an alternative. We have string replacement function if you do more than search. So if you want to do replacement, but you are fine with just replaced by string, not by regular expression, prefer that instead of that. In the future, what I'm planning to look is sort of caching for this large regular expression. So if I see a parameter is really large, then maybe it makes sense to cache the value and the compiled version. However, overall, I haven't seen any big difference in performance with what I tested. But again, with this registration was not much done there. Otherwise, in terms of the rest of the parameters, we anyhow do evaluation of the variables you provide. So now the evaluation of the variable is done by Lua Python. Otherwise, in Kamailio, it's done by our fix-up mechanism. So it's still a layer of evaluating the parameters, and then it's the same function executed. So from Lua comes with parameters as string or integer, and we execute that code. For Kamailio CFG, first is this layer, evaluate the variables, this $RU, $CI, or whatever, and then execute this common function, which is, again, it's the same code executed by Lua or by Python or by a native interpreter with a layer of fix-up by native scripting language and the layer of compilation by Lua and Python, which is done independent of us, and I don't have any like insight of how they do it because I haven't studied this. Now related to the variables, because these are specific to Kamailio, and what are the differences here. To optimize, practically it's better that you get a value corresponding to, like here I have the example getting the user agent value, the header. You can store it in a local variable. Here it's Lua, but you can store it in Python and use that because, again, the interpreter of Python is optimized for its own variables. Here behind this is practically calling a function behind, which is looking up the variable. It's evaluated the value and returning back to, in our case, Lua. So I get it here, and then I use this variable with practically here we have a Lua-specific string find. I don't use the search from Kamailio functions. And this is important to have in mind. Then be careful with definition of variables because some of them have a variable name like $var, and you choose your inner name there, or more specific also to the hash table, where what you put between parentheses in Kamailio config file, it's up to you. Don't try to define many of them because we create a structure. We have a caching mechanism that is kind of cleaning it, but it's better to avoid that, and I will have a dedicated slide for it to understand better this issue. But the idea is try to get into that scripting language, the values, and work with them instead of just calling back into Kamailio to get the value of $1 something. An alternative would be, which I started at some point, and maybe we'll extend it a bit more. There is this zip.json module, and for each zip request or reply, can create a JSON with the main attributes that practically I was looking at my configs, and I saw I use a lot of source IP or request method, request URI from URI. So it's practically creating a JSON, and with JavaScript or Lua with Python, you get this and you map it into one of their native structure, and then you access it by the index. So you just serialize the SIP request, you get that JSON, which you pass it, or you fetch it into the, here it's again with Lua. The example, practically, I use the Lua CJSON extension. I load it in my script. I use KSR SIP.json, HJ serialize. Here are some flags, what attributes to serialize and put in the JSON document, then where it's stored, and then I decode it in a local hash table for Lua, and then I access it with the name of the hash table I choose, and this will be like the name of the variable from Kamailio, and then it's also faster and better from this point of view. Then for the variables, also setting the value sometimes could be a bit expensive in the way of, search for the class of the variable and then parse it and then set its value. For a couple of common variables, now there are a dedicated set of function, especially as I use a lot hash table, I started with it. So instead of using pseudo variable related function, you should use those from hash table, the module which actually implements those variables, where you have a function and you kind of split in a couple of parameters, and it's faster from this point of view. There are also ongoing work for XAVPs to have this dedicated function. So right now it's adding, removing, already implemented, but I plan to extend it a bit more. And also some functions offered by codecs in terms of testing request URI username part or setting the send socket and so on. Those common ones I try to offer as a function to, as an alternative. Again, some of them were not really like critical from point of view of performance, but I find it also a bit easier to read and understand. The only thing with the variables and also with the native scripting language, which somehow it's a feature in the way that you can easily read and understand, but doesn't have like error handling in behind. If you set request URI and allocating space for the new request URI fails, you don't know. I mean, you've seen the error logs, but in the config file, you don't have like a return code that the assignment failed. With this function, you always test if it's successful or not. So sometimes this using function mechanism, it's better from error handling point of view. What we had also specific in Kamailio config file are these keywords from the core, very old implementation from the early phase of SIP Express router. All this kind of myself condition, testing for protocol and so on. There are kind of dedicated function that replace those conditions. So if you want to test if request URI has a local domain or from URI or to URI, you can use this function. Also, if you want to test if source IP is the same as the Kamailio, there is a function for you. So prefer dedicated function instead of generic is myself, where you put a value which you actually fetch it first from Kamailio in the Lua script, and you put it back to Kamailio to parse it and do this myself condition or so. Also, this kind of, we had this regular expression on matching on the request type, invite by. There is one where you can call is method in, and practically there is a set of flags, which are the letters, typically the first letter of the request. When it's a conflict, it's another one, but it's documented on that KEMI tutorial. So look for this one if you have a lot of such conditions. So again, if you just test it once or twice in your config file, it makes no big difference. But if you use a condition for many times, it's better to use dedicated functions for it. Also, like for method, instead of getting the method as a string and comparing with this string, we have all this is invite, is cancel, is register, it's whatever method type it's defined by the standard. Now, as many people were concerned about performances, we are not alone. So two well-known and high-performance oriented applications out there are using Lua. So Redis, probably this is also very famous in Kamailio, also with replication for the RTP engine, but also NGINX, which is now the most popular web server, and at least reverse proxy took over Apache. They use Lua, embedded Lua, and again, it's very performant from this point of view. I gave a link if you want to look at the list of other applications, but I choose only these two to give an example. And of course, besides this optimization that I gave here as a hint for our variables, which are specific for Kamailio, and the keywords, there are a lot of other benefits. So lately I was deploying quite a lot, mainly Lua, because the customer, they have easier ways of learning that language. There are tutorials about Lua, there are blogs about, they can forums and so on. I can say, actually, I'm Lua because I started with Lua, but from community interaction, I think Python is more popular. And we have also Python 3, and then you have a lot of extensions and a lot of tools to play with the language, learn it, debug it, and so on. And of course, don't forget about reloading. It's working smooth. You change something in your Lua Python script, send an RPC command, and you have the new one executed. And actually, there are other additional scalability mechanisms. So you can create a thread to do some blocking operation, and you know that you don't block Kamailio. Threads, coroutines, that are coming with Lua and Python. So there are benefits apart of just this scripting language and also being a fast one. So trying to be in time with the boat trip, that's like my list of hints. Again, remember with module function, typically it's about parameters, and only for this regular expression that might be a bit difference, but otherwise finding the function, executing it is the same code. And then will be these very specific Kamailio elements, the variables and the keywords, which are implemented in Kamailio. We have function to get set values, but for these very common operations, I added some dedicated functions, so it's somehow also easier to handle for error cases, but also a bit more optimized in the way that you don't fetch a value from Kamailio to Lua and put it back to test if it's a local domain or IP address. So if you have one question or two, not to get too late. Otherwise, I'm around here, but probably also busy. Anyone with a question? Or now we have Armen there.
Hello.
Hi.
With respect to the Python integration with KEMI, is the Python global interpreter lock shared by all of Kamailio, or does each process use their own?
We initiate the interpreter per child, so per process, so it should not be this global lock. It's why it's fast, and I think Python 3 doesn't have it anymore, or has it. But again, it's the last results, and maybe the Python fan here can test it. I was surprised to see that Python is really, really fast comparing with what I did 2 years ago. Other question? Otherwise, I'm trying to put again the boat trip. Okay, sorry. Okay, so then just before, can you put again the slides? So everyone is welcome to join the boat trip. We'll have drinks, as much as you can have in these 2 hours, a bit of food, but not much because you might fall into the Spray River. And then also a bit of food like takeaway currywurst or this vegetarian boulette. But if you are really hungry, maybe you sort out a bit early or wait until 9. We start at 7:15. Try to be there by 7 just in case, you know, it takes time to get on board, or we'll see it's first time we do it, so we don't know what to expect. Thanks to Sipgate, which organized it. It's not far away again. You just go out here, you get to the river, left side, and just before the first bridge, so 100, 150 meters, you go a bit down is the DDR Museum. The boat trip, Maria, if they haven't changed it, but should be this one, and the company Berlin Wasser Taxi. I should be there as soon as people leave this facility. So again, it's 1 hour if you want to spend it in a way or another, but here probably we need to close this room, so you need to get your stuff out of here. You can still stay on the hall for a while.